Hi, in this video we are going to do a comparison between the initial buck converter design with the Schottky diode and the new design with synchronous rectification, which in fact is the design we have here. We are going to do the comparison in terms of power losses and size. So let's see the results. Here we have the power losses for each design, and well, you have here the color code. In blue you have the conduction power losses of switch SA, in green the switching losses of that switch, in red you have the conduction losses of switch SV, and in gray you have the power losses of the inductor, which basically is the power losses we have in that series resistor that we consider in the simple model of the schematic. Well, why we don't have switching losses in switch SV? The explanation is included in previous videos, as we saw, both in the case of the Schottky diode or in the case of synchronous rectification, switching losses in that switch are negligible. So, as you can see in the first design, the power losses, the total power losses were 6.6, and now we reduce a lot that quantity because we obtain 2.5. Where we have the improvement? Basically, the improvement is in the conduction power losses of the second switch, SV. When we replace the Schottky diode with a MOSFET, we obtain an important improvement in terms of conduction losses, and basically if you check the simulation and you evaluate the power losses, you will see that this improvement is around -4 watts. Okay, so we're reducing this quantity with -4 watts. Okay, let's talk about the size. So here we have the size for each design, and the color code we use is in blue you have the capacitor size, in green you have the size of switch SA, in red you have the size of switch SV, and in gray you have the size of the inductor. As you can see, the capacitor size is negligible in both cases. Basically we use the same capacitor, which is in fact implemented with 5 capacitors in parallel connection. The size of the switches in general is negligible. It's true that in the second design we achieve an important improvement in terms of this size, because, well, the size of the MOSFET is smaller than the size of the Schottky diode. That's why we reduce the size a little bit in the second case. And the main problem is that in both cases the main contribution to the size comes from the inductor. So as a conclusion, this is something that we want to improve in future designs. We will try to reduce the size of our design by minimizing the size of this inductor. But, well, until this point we finish with the target. We finish with the topic about synchronous rectification. So thank you for watching and see you. Bye.